Hi, my name is Tim Quinn. I'm a member of Oracle's engineering team working on Project Helidon. In this video, I will be talking about some recent enhancements in Helidon Metrics. Observability is a key part of a well-designed microservice. Metrics is an important facet of observability, and Helidon's support for metrics draws from the microprofile metrics specification. There are two variations of Helidon. Helidon SE includes a reactive web server, which you have access to as you write your Helidon SE application. There's no magic in Helidon SE. There is no injection. There is no annotation processing at runtime. Everything that you want to happen, you write in your own application code. And Helidon SE implements metrics that are inspired by the microprofile metrics specification, although SE does not implement fully that specification because there's no annotation support in SE. Helidon MP, on the other hand, is a full implementation of the Eclipse microprofile metrics specification. It includes full support for annotations, interceptors, and so forth. Both SE and MP provide built-in support for a metrics endpoint at /metrics, where a client can access to obtain a listing of all the metrics, their values, and their metadata. There's been a number of recent enhancements we've made to the metrics subsystem in Helidon over the past several minor releases. Recently, we released 2.4.0, which is a significant feature and bug fix release, but there have been a number of improvements dating since our 2.2.2 release. These include micrometer support, support for exemplars, metrics describing thread pool executor behavior, some extended key performance indicator metrics, the ability to enable and disable metrics either overall, the extended key performance indicator metrics, or control metrics by the registry type or scope and the metric name. Micrometer is a very popular metrics API, and Helidon provides micrometer support in both SE and MP. In SE, we provide a built-in meter registry, which your application can get access to using an API, and we provide a built-in endpoint for retrieving micrometer metrics using /micrometer. In Helidon MP, our micrometer support includes what's in SE plus full support for the micrometer annotations and a built-in injectable meter registry, which your code can use to explicitly access the registry, adding new meters, retrieving meters, and so forth. There is a separate YouTube video that describes the micrometer support, and I encourage you to take a look at that. Helidon also supports exemplars. We mentioned observability earlier. Metrics is a key part of that, so is tracing. In metrics, each request contributes a sample to aggregate values that are measured for the whole application. Tracing, on the other hand, typically counts and times the work done for an individual request. Exemplars bring metrics and tracing together by associating a representative sample, that is, a given request, with an overall aggregate metric value. The Open Metrics or Prometheus metrics output format shows exemplars. There's also a separate video describing the exemplar support in Helidon. Within Helidon, there are a number of thread pool executor services which do work concurrently within the application, often behind the scenes, but your application can also make use explicitly of executor services if it needs to do work asynchronously itself. The thread pool executor metrics give some visibility into characteristics of the executor services, such as task count, pool size, and queue information. The exact metrics that are available for a particular executor service depends on what specific type of executor it is. We'll see some examples of this later on. Key performance indicators are some automatic metrics built into Helidon that allow you to get an idea of how well your application is serving requests over a period of time. Let's take a minute and talk about one way of looking at the request lifecycle, at least from the perspective of metrics. When Helidon receives a request, we consider that the request handling has begun. At some time after that, work actually starts in performing the work implied by the request. We refer to this as request processing. At some time after request processing has begun, a response is sent back to the client. At this point, we consider the request handling work done. And if processing is done synchronously, once the work is completed, then the response is sent back to the client. But Helidon supports asynchronous request processing as well. And in this scenario, the work that Helidon is doing or your application is doing in response to the request might actually continue past the point at which the response is sent back to the client. During this async request processing time, resources within Helidon and within your application are still working on behalf of the request. Eventually, that work completes, and at that point, we say that the request processing has finished. Helidon includes some standard KPI metrics by default. There's a counter that simply counts the number of requests over time that have been received by Helidon. And there's a meter that not only counts the requests, but also measures the rate at which they are handled, an average, and then 1, 5, and 15-minute rates of request handling. There's a set of extended KPI metrics. These are turned off by default. But if you turn them on, then you can get some further insight into how your application and how Helidon is handling and processing requests. In-flight requests are measured by a concurrent gauge that gives you some insight into the number of requests being handled. Long-running requests are captured by a meter in which the handling of a request exceeds a configurable threshold. Defaults to 10 seconds, you can override that. The current load is measured by a meter, which exposes the rate at which request processing is being completed. Deferred requests are measured by a meter, which measures those requests for which processing begins sometime after Helidon has actually received the request. This gives some insight into queuing that might be happening within the application or within the Helidon infrastructure itself. There's a number of ways that you can control the recording and reporting of metrics within Helidon and within your application. We just mentioned how the key performance indicator metrics include the standard ones by default, but the extended ones are disabled by default. You can turn those on by setting metrics, key performance indicators, extended equals true. And if you want, you can control the threshold that determines whether a request is long running or not. The default is 10 seconds. This setting would set it to 2 seconds. You can also control overall metrics with one setting. In the configuration shown in the middle of the slide here, we simply say metrics enabled is false. In this case, no metrics within the system or your application are updated, and accesses to the /metrics endpoint return 404 and an explanatory message that metrics have been disabled. You can also control metrics by scope and name within scope. Recall that metric scopes can be base, vendor, or application, and each metric is categorized into exactly one of these scopes. You can enable or disable an entire scope with a single setting, and you can also use some finer grained control over particular metrics by name by specifying some regular expressions. You can specify patterns to exclude as well as patterns to include. These are regular expressions, and if you specify exclude and include together, then exclude will override whatever you might say in include. The example in the lower right on the slide shows that this user has chosen to disable all vendor metrics and has chosen to allow only a subset of all the application metrics that are recorded and reported. In this case, the filter requires that in order to be recorded and reported, a metric name must start with my app, be followed by a dot, be followed by some number of characters, and then end with the word updates. Any other metric name that does not match that pattern would be rejected and would not be recorded or reported. And we'll see some examples of this later. Helidon applies the following conditions to decide whether to update or report a metric. Overall metrics must be enabled. The metrics registry scope must be enabled. And it must be true that the metric name does not match an exclude pattern if one is present for its scope. And either there must be no include regular expression pattern, or if there is an include pattern, the metric name must match that pattern. So now we're in a good position to take a look at our demo. We'll start with the Helidon MP Quick Start application. We'll take a look at the default metrics that we can observe. We will turn on the extended key performance indicators metrics. We'll disable metrics entirely, and we'll also add some custom metrics and then apply some filtering to see how that works. I have already used the Helidon command line, Helidon init, to create the MP Quick Start application. I'm going to use another subcommand, Helidon dev, to start the dev loop, which will monitor the files in our project. Anytime one changes, it will stop the server, rebuild the project, and then restart the server. Now that the server is up, we'll take just a moment and put our application through its paces. The Quick Start app is a very simple greeting application. We ask it to greet us, and it says hello world, or we can ask it to send a more personalized greeting by adding the name to the end of the path, and it will reply with that specific personalized name instead. So we'll do that a few more times. Now we can ask to look at the metrics. We'll require that the response come in JSON. So we can format it more easily. And what we see is we have the key performance indicator metrics, the standard ones that are automatically recorded and reported for us. We have a count of the number of requests, and we have a meter that tracks the number of requests and the rate at which they've been arriving. We also can see information about the executor service metrics. Now, if we look at these carefully, we can see each of the executor services has an active count. This is the number of threads in the thread pool that are active. We have a completed task count. And we have a total task count over the life of the thread pool. There's also largest pool size and current pool size. And there's also a remaining capacity of the queue that's holding tasks that haven't yet been run and the current queue size. There are two copies of each of these metrics because there are two thread pools, and those identities are conveyed as tags in the metrics. These various tags are constructed so that each separate thread pool, each separate executor service will have a different set of tags so they can be uniquely identified in the output metrics. All right, so if we go back for just a moment, here we have the two standard KPI metrics. We can go ahead and have Helidon also record the extended set of KPI metrics. So we do that by simply changing the configuration so it reads metrics, key performance indicators, extended equals true. In this case, we've also chosen to override the default setting of what qualifies a request as long running, so that instead of the default of 10 seconds, we're going to use 2 seconds. We won't actually see that because none of our requests will take that long. So we'll let the dev loop digest that change in our application file. And now we will send a few more requests. And now let's retrieve those metrics again. So we see we've got the requests meter, which we had before, but now we also have long-running requests. We have load, we have in-flight, and deferred, as well as the count. So simply by changing the configuration, we were able to enable those extended KPI metrics. Next, we're going to add some application-specific metrics to our application. We'll go to the application source code. This is the JAX RS resource class, which contains the endpoints for our greet application. And there's two Java methods, getDefaultMessage and getMessage, that respond to the get requests that are sent to our application. We're going to add a counted annotation so that we can set up a counter for all the get requests that our application receives. We're going to set absolute equal to true, which simplifies the name a little bit, and we'll set reusable to true for this counter. We set reusable to true because we're going to use that very same annotation and therefore the very same metric for measuring the personalized greeting requests and also the generic greeting requests. Let's also add a timer for the personalized greetings. And we'll choose absolute equal to true here. We don't use reusable. We don't need reusable equals true here because we're only using this metric in one location. Having made these changes, we'll click down in the terminal window. That will cause the IDE to write out the changed file, which will cause the dev loop to discover the change and rebuild and restart the application. So now let's send a few more requests to our server. And now we can retrieve the metrics, but we can limit those metrics reported to the ones in the application scope. And that will include the two new ones that we just added. And now we can see we have gets, which is the counter that we added that was measuring both of the methods, and there's a total of 5. And then we have gets.personalized, which was measuring only invocations of the getPersonalized message. All right, now let's come back to the configuration file, and we can see how we can control the recording and reporting of those custom metrics. What these two configuration lines do is they say that we want to impose some registry-based filtering. In this case, the registry we're controlling is the application registry, and we're applying an exclude filter that will rule out any metric that matches this regular expression. This is, in fact, in this case, just a fixed string that's going to rule out our timer that used the name gets.personalized. And the dev loop has come to life. It has rebuilt the application. Now we will send a few messages to our app. And now let's retrieve those application metrics again. And now the only application level metric reported is the gets because our filtering excluded the personalized get timer. All right, let's do another simple change to the configuration file. We're going to completely disable metrics entirely. We'll set metrics enabled to false. The server has rebuilt and restarted, and we will go through the same steps here. Send a few requests to our app. Now, if we try to access the metrics endpoint, we're going to get a different result entirely. Here we're getting a 404 and an explanatory message that metrics has been disabled. In fact, behind the scenes, even though the code is in the application to update those metrics, Those updates have never really occurred because we had turned off metrics. So not only it's not just the reporting of metrics that's turned off, but also the actual updates to the metrics themselves. So there is a quick overview of some of the more recent changes in Helidon's metrics support over the last few minor releases. If you want to learn more about this, you can go to the helidon.io/docs website, navigate to Helidon MP, and then to Guides, and then to Metrics, or similarly to Helidon SE, and then to Guides, and then to Metrics. You can also look for clickable links in the video description, and you can click on the other related YouTube videos that we mentioned earlier in the presentation. Thank you very much for joining me for this video about metrics and Helidon.